All right, picking up from where we just left off. So part F. To derive this function, I first will have to expand the brackets. Take 7. So I'm applying the first term, or multiplying the first term by every term. So this gives me 2 times 3 is 6. X squared times x makes x cubed. -7 times 2 is -14 x squared. Now that I've got expanded brackets, I can find my derivative function. So this is my f of x. So therefore, when I'm deriving, I use notation f dash x. 6 times 3 gives 18. X to the 3 take 1, which is 2. Minus 14 times 2 is -28 x to the power of 1, and we don't write the power of 1. So that's my derivative function for part F, question F. Looking at question G now. So I'm given a fraction here. So first, I'm going to need to simplify this fraction. So I'm going to split it into 2 fractions. So I'm going to get 3x squared on 2x plus 5x on 2x. So I'm just splitting this right down the middle, and both of the top terms are over 2x. So here I can cancel through, which makes things a bit simpler. So I can get rid of x there and x there. So I'm left with 3 on 2x. And then same thing with the second term. I'm cancelling my x's out. I'm left with 5 over 2. So this is my y equals. So now I'm going to derive that I've simplified. So a derivative function. Now x is to the power of 1, so 1 times 3 on 2 is just 3 on 2. X to the 1 take 1, which is 0. And then remember my constant terms. Again, I've got a constant here. They just cancel out when I derive. So this here equals 1. So I've got 1 times 3 on 2, which just equals my 3 on 2. So my gradient gradient function is 3 over 2. And question H there is pretty simple. All it's introducing us to is just the fact that we don't always have to be deriving in relation to x. So we can be deriving in relation to any variable. In this case, we're doing it with respects to r, and we would apply we'll derive it in the same function that we would do for x, except we just do it with respects to r. So at the moment, this is how we'd write the notation. So usually we'd have function of x, but this time we've got function, or s stands for function as well, function of r equals 6r squared take 12r. So therefore my derivative function, or s dash of r, equals same way we treat it, 12r to the 1 minus 12, which just gives me 12r minus 12. And that's it. So as you can see, a lot quicker than what we did in the previous exercise by first principles, and just a few sort of simple rules to remember, and you should get these down pretty easily and pretty quickly. So you shouldn't have many issues here, I don't believe.